Morning guys, welcome to again, welcome to my presentation. Today we're going to talk about gas consumption. Why is this important to you? It's important to you because, hey, you don't want to run out of air. If you're going to be a self-reliant diver, part of that course. If you're going to be a tech diver, it's a very important part of that course. Also, with your customers, sometimes it's very, very useful to be able to reassure them that they're not going to run out of air during the dive that you're doing. So we're going to do two presentations. This is the first presentation, and we're going to talk about very, very simple gas consumption calculations. Okay, we're going to keep this one in salt water. We've mastered working pressures out, so we don't have to worry about going to fresh water. It's all about atmospheres. So keeping it very, very simple. Here's my water. Again, I'm addicted to drawing drawings. I'm at the surface. I'm at 1 atmosphere. I haven't really got a drawing for breathing, yeah? So I'm just going to draw a tank, just to remind me what I'm doing. And from this tank, I breathe 1 bar per minute. The surface. I think you'll see what's going to happen here. If I take it down to 10 meters, 2 atmospheres. Now each breath that I take there to fill my lungs is double density. Do you remember the density? Yeah. So now I'm going to breathe 2 bar per minute. And so we continue, 20 meters, 3 atmospheres. I'm going to breathe 3 bar per minute. A very, very basic principle. So I can take my breathing up and down, but this is a very, very easy example. Let's take it one stage more complicated. Again, 1 atmosphere, again, salt water. And this time I'm going to say, here's my tank. My tank lasts 30 minutes here. And my question wants to know how long will it last at 30 meters. So I go to 30 meters using something I already know. I know that 30 meters is 4 atmospheres. I'll draw my tank again, so I like drawing. My tank, each breath I take is going to be 4 times as dense, so it will represent 4 of these breaths. So my tank will last 1/4 of the time. So on the way down, this pressure here, 30 minutes is less time, so it's divided by this 4 atmospheres. So I get 7.5 minutes down here. Let's go one stage further. Here's my water. I'm going to start this time underwater. I'm at 15 meters, where my tank lasts 40 minutes. And I want to know at 30 meters how long. Let's fill in a bit more information than this. Needless to say, I'm going to take this to the surface. This is in salt water. This we know is 2.5 atmospheres. This we know is 4 atmospheres. Now be careful here, because don't forget that this time I'm going to get more time from my tank. I'm breathing it at the surface. So time has got to go up. Let me draw the tank on the surface just to be consistent. So my 40 minutes I'm going to get more time. How much more time? 2.5 times more time. So it's going to go 40 minutes times 2.5. And that equals, if you want to do that on here, 40 times 2.5 equals 100. 100 minutes. So I worked that out, that's good. Good. Now I'm going to take the same tank down. Obviously my time is going to decrease because I'm now breathing at depth. How much less time am I going to get? I must divide by 4. So I go 100 minutes divided by 4. So down here I get 25 minutes. It doesn't matter what numbers I plug into this equation. If I put fresh water, it just changes these numbers. It changes this multiplier and this denominator here. That's all it does. You can do any question using those calculations. Bring it up to the surface first, I would recommend, then bring it back down. This all makes sense because it's gone to the surface. If you want to see a slightly more complicated version, or you're doing something other than having trouble with your exams, you'd like to learn a little bit more, please look at presentation number 2.